that software process, how we are dealing with the coupling and the cohesion. These are the problems that causes majority of the software issues and how we are addressing each level. That's my topic today. And Pandiarajan, I work as an architect. So everybody told you about a hobby. So my hobby is trekking. Check on that. I'm straight away going to the slides now. I have divided my session into 4 parts. First is the code level, how we are addressing the problems of coupling and cohesion at code level, then at the class level, then at the module level, then at the system level. So 4 sections. The first section is, you see, at code level, you see this code. And what's the problem in this code?
Too many parameters.
So many parameters, right? So the technical term for this problem is it's primitive obsession. That's the violation here. I mean, it's a code smell. The code smell is primitive obsession. What I'm trying to use is, instead of using a class and object, I'm using the primitive data types here, and I over-influence the primitive data types, and I'm creating a method like this. So the solution is obvious, you know. And so this kind of a code problem, software engineering gives the solution in terms of what? What kind of solution the software engineering gives us? Code problems. Any code problem that we make, it's a single line of code, small set of issues. Okay, let's fix the problem. I'll tell you the technical term for it. See, I fixed the problem here because all of them have been put into a class, and the solution is encapsulation. It's oops. That's the solution. I put everything into a class. Code level problem. Okay. Then to the next level. The next level is the class level. So now that's a new requirement. Okay. My product manager comes and tells the report has to be generated at 2 levels. One is at the user level. Assume that Pandian holds a bank account. I hold, as a user, I hold many accounts. One is the credit card account. It could be a loan account, or it could be of any other accounts as a user. So the report has to be generated at the user level. It's combination of everything. Sometimes I need the report at account level. Okay. So you see this requirement, account level and user level. Okay. So for this, I changed my code like this because I have already captured all the information into report parameters. Now report parameters is a class. Assume that we have a method that generates automatically all the report parameters. Okay. I'm sorry. Okay. So what are the problems that you see here? Exactly. Yes. Yes.
Can be bifurcated into 2 different methods altogether.
In terms of
Generate report for account type, generate report for user type.
Factory design pattern. Factory design pattern
factor design pattern.
can be.
Okay. I'll tell you. So even if you create as 2 separate methods, again they are going to call the same thing. Again, there must be a decision taken at the top level. Who is going to call? That will not solve the problem, but you see this problem. So what I am trying to say is, even in the previous slide and this one, the problem is, I'm going to the previous slide. This is tightly coupled with these 20 things, and we want to have loosely coupled system and high cohesion. The problem here is the cohesion, because you need to organize all the relevant information elements into same into your content. Sorry. of coupling and cohesion. The coupling here is, this method is tightly coupled with entity type, tightly coupled with this generate account report, tightly coupled with generate user report, right? So if you look at it in coupling perspective, these are the problems of this code. So to solve this coupling problem, what are we going to do? What does it violate? It violates open closed principle. Somebody has correctly mentioned that when we have a switch statement, we are going to have a switch statement soon, because right now it's going to be user level, account level, sometimes it will be product level, asset level. We are going to expand this. It's a clear sign of open closed principle violation. And you see that another problem here, I'm having an account report, I'm having a user report, and I'm going to have all these things, but do I have the corresponding encapsulation for them? It's not a bad data, it's a violation. Again, whose violation, right? So the problem here is, what we see is, when I say open closed principle, it's a design principle. Design principles tells the software problem. Okay. So to solve this issue, the user report issue, first problem, that's a fundamental problem. I have a user report, I have an account report. I need to have user class first. In that class, take the responsibility of generating the report. I should not generate it at the random class, right? So I'm creating a user class and I'm writing a method generate report. So I'm coming to the part of iReportable entity. That's for interface. I'll come back to that. I'm creating an account class. That class has generate report. Now iReportable entity. So this iReportable entity is the problem that is all spotted, that violating the open closed principle entity type. Because if I have one common interface, then I will be able to call regardless of whatever entity type that comes in. I'll simply call by passing the interface here. Then it will solve my problem of open closed principle. Okay. Single responsibility principle solves this. Creating a user class or an account class is the solving the problem of single responsibility principle. Principle is single responsibility, but what you have achieved is design principle is telling the problem, design pattern is solving the problem. So we have created the class. This is in oops, this is encapsulation. We have encapsulated them. So now we got this. You see this generate report now? It's very clean. Now it does not violate any open closed principle. All put here. Are you all with me? Easy. Now there is no if condition here. Now what I need to do is, this iReportable entity has to be injected from dependency injection. So when we talk about solid principles, the design principle, solid principle is one of the design principles. What we have seen so far is single responsibility we have seen, and then open closed principle we have seen. Now we are seeing the third one, which is dependency injection. So what I need to do is, I need to inject them because it is dependent on this iReportable entity, and we are resolving them using the dependency injection. This is written in Unity. There are many various tools. I use Unity. Unity is the dependency injection a tool in C#. I did not resolve this purposefully. Why? There's another dependency here, another coupling. It was tightly coupling with the iReportable entity. Now it is tightly coupled with this report parameters. So again we are going to solve this problem. Again, same. We are going to the interface, same. So I create iReport parameters, dependency injection again. Now this is key. All good so far. So in this way, reports, another type of report. Okay. So in this case, what I have created is, I have expanded this existing iReport parameters interface. So what I am trying to achieve here is, you see this in my previous case, iReportable entity, I used to pass iReport parameters. It must take another parameter. We know that. In the existing iReport parameters, I have included now SSRS username, SSRS URL, SSRS server, report state, all the SSRS related items here. Now, when I do this, what is the problem here? You see the problem? This question mark. What is the meaning of this question mark in C#?
Nullable
Optional. You could pass them or you can miss it. String is still a nullable thing, and I want to make very clear that it's an optional thing. So now what happens is, one set that goes, that the regular reports are generated by report ID, report name, start date, end date. SSRS reports are generated using SSRS username, SSRS URL, server, report state, start date, end date. It ignores the first two. So what is the problem here? Coupling. We are tightly coupled here. Tightly coupled with the iReport parameters. Again the same problem. It is low cohesive because this does not belong to, in this SSRS reports, does not belong to these regular report parameters, right? So I need to create this. So the problem here is, again, the third problem that we have seen is highly coupled, low cohesive, and we have created we have to create two different interfaces. What is the solution, name of this solution? Design principles, again.
Interface segregation.
Exactly. Interface segregation principle. Yes. We segregated the interface. Now, you see this iReportable entity has two different methods because it can be generated either by regular report or SSRS report. Account also has to generate two different type of reports. See this SSRS report or regular report. Okay, now we have this code here. You see this problem. Fourth problem we are saying here. So now I look at the interfaces. But yeah, two types of report parameters. That's the problem here. You see this one, I need to pass. The entity is there. I know I can decide which kind of entity. That's from dependency injection. Again, iReport parameters is there. But for each entity, which type of report the user also going to send it, and I'm going to put another if condition here. Decide is it an SSRS report or is it an regular report? Sometimes it will be a Power BI report. Again, it will come. Again, we are going to the same problem here. So what happens here? What is the issue here? This interface segregation principle is complete. So what I need to do is I am creating two different methods in iReportable entity. Okay? So iReportable entity should encapsulate what kind of report it needs to generate. It's not the responsibility of this method to decide which report to be generated. It makes sense? What I am trying to do is, if you notice the problem is here, there are n number of entities that we are going to generate report. It could be user, asset, account, n number of them. and n number of report tools that we are reporting tools that we are going to use. It could be Power BI, SSRS, or a regular report, a HTML report. So we need to marry these two list of combinations. It's a combinatorial explosion. N into M, correct? So that's the problem here. So for this kind of problem, it's a dependency. You see it's a coupling, right? So what I'm trying to create is I'm trying to encapsulate the type of report each entity that is going to generate at the constructor level. So when I encapsulate that information at the constructor level, what will happen is you see this, the account class, I'm replacing the account class. I tell them what kind of report that I want now for this account class. So at the time of generating the report, I take only one parameter, which is the entity, reportable entity type. Okay. And I don't take the other parameter. You see this generate report method, it does not belong to this class. You don't have to continue the class. This is a separate class. This is the class that we were already trying to use. So in this class, what I have done is, I separated the method, like one of you have already told that you need to create two different methods. At that point we should not create, but at this point we should create two different methods, because these methods are invoked by the user interface. When you click a button of generate SSRS report, this method will be called. They click the button of regular report, then this method will be called. Any questions so far? I'll go here.
What if there is a common button, and on the button, so here the rule of thumb is you identify from the user point of view what he is clicking.
Right.
So we know what method to run. But what if there is a common button, right? Which okay, that is technically not possible.
Possible, right? Yes.
A little dumb question maybe, but by looking at the method signature, how are you telling if there is low cohesion or high cohesion?
Okay, because if you see this, okay, it all started from here, is it?
Yeah.
From this point,
Correct.
how you are done. Okay, so the core smell here is, you see, in this case, the coupling is of multiple report parameters. When I say I report parameters also, it depends on, SSRS reports also, parameters also it depends on, and it also going to be dependent on any new report that is going to come. And the parameters of this method is going to expand further and further, and I am going to add more and more if conditions here. So which is, one way of looking at it is, it's tightly coupling with many other items, and another way of looking at it is while it's open closed principle, which is the if condition, multiple if conditions.
Or one of the could be you can create a separate class for separate report.
Might be, yeah. So everybody.
Hello? Yeah, so another way could be we can create separate class for separate report and can pass as a activity injection.
Yes, that's another way. So separate classes, there's a need for creating classes.
Like design pattern.
Design pattern, yes, it's an encapsulation. So here the encapsulation that we need is, the encapsulation is at an individual level, but the hierarchy is not correctly organized, which is also a strategy pattern. So what we are trying to do is, in other words, so every time when you are attempting to solve a design, it's a design principle. Design principle and the okay. Yes. Every time you attempt a design principle you come and solve the problem. It comes into handy that you are creating a design pattern. Design pattern is the solution provider. Design principle is the problem identifier. So you are identifying the problem of open closed principle. Open closed principle is because of either you need to use strategy pattern or you need to use right level of coupling. So in this case, what I have done is, instead of using the multiple small items, multiple small classes here, rather I capture them under reportable entity itself, in the same class itself, which is a strategy pattern. Now it's going to be I report parameters, ISSRS report parameters are part of I reportable entity, which means I use them as a, you see this, it's a strategy pattern. So because those two classes are now part of account. Account has a relationship with report parameters. And the flexibility here is, if account does not need an SSRS report or Power BI report, I can dictate that what kind of elements that I want to use. That's another option here. So that's a strategy pattern. That's how I can do it. Okay. So this strategy pattern also becomes a bridge pattern because it's an n cross m, right? Because in this case, what I have done is n number of reports, n number of entities, and m number of report types. That becomes a combinatorial explosion. So to solve the combinatorial explosion, if we apply this kind of a strategy, this is called a bridge pattern. We are bridging it.
Here also the number of report types keep on increasing. Now here you assume that your report type is 100 different types.
Correct.
This will also be
Yes, what kind of reports, how I am handling it, will be within this class. We reduce the level of coupling at the top level class. Yes. There are solutions for this as well. If it goes further and further, we go for another approach. What is the so as he says, the number of reports keep increasing it and the constructors are keep increasing it. What is the solution that we think of? Single pattern is one, and but the best approach is create them all in a factory. Factory is meant for that. So I will be going back to see this in database. So we already have seen so far. Every time software process at code level, at class level, when you see a coupling, you solve them using design by understanding the design principles and take the solution from design patterns. Okay. So, and all these things are the problem of coupling, and you move the new approaches that brought in, oops came late, and the design patterns, design principles all came late. You solve them using the by decoupling and highly cohesive data. So it happens in database as well. This is in zeroth normal form. Obviously, you see these orders, right? So the same problem applies to everywhere. In database also, this problem is there. So now we have done two levels. One is code level and class level. That comes an interesting part. It is very interesting that you see it in component level. When you see it in the component level, even components are tightly coupled to each other. Okay, I create one module and the another module is tightly coupled. So what do you need to do now? So one is at the hardware level. Okay. So another one is remote procedure call, because at module level you are calling in another system or somewhere, whatever happens, you need to call. So in that way you need to decouple it, and database calls. All these are all common, because when you are making your program is reading a COM code, how long does it take? We don't know how long does it take. It depends on the system's performance. It's going to take its own time. So in those cases, we don't want to take the risk. What we need to do, we put them under separate class. Ensure that our software code is decoupled with this hardware code, and any failure that happens, it happens within that class. It does not affect my regular code. Okay? So that's how I decouple it. Same thing, any call that I make to an external system, let's take WCF for an example. We have a skeleton classes, and anything that I am calling to a WCF method, I put them under a separate class, ensuring that any problem of the external software or other system does not affect my code. And including the database calls. Database calls, what we do? How do we approach? We don't directly write queries, right? What do we do? ORM, correct. The ORM is a tool that encapsulates all the database calls, and it's a wrapper, right? So all these things we use wrapper, right? Wrapper class. So now I'm moving to the next part, which is the service-oriented architecture. I talk about the monolithic architecture. Before service-oriented architecture, it was monolithic architecture. So the problems of monolithic architecture that you all see, deployment problem, because you cannot take no time to market because it's a very big one, and every code change that I make in monolithic, single big fatty application, one code change does not, it's not just one module, right? You are going to deploy the entire application. I need to understand what are the dependency, the testing has to happen full level. So it's very big, and it's not just the one thing. All these things, all these problems are there in monolithic. Okay, so that's the reason. So that's a software problem. Okay, and this software problem, monolithic software problem, is because of what? Coupling, tight coupling, right? So we need to make it as a tight coupling and low coupling, highly cohesive software. So what is the solution that we have? Microservices, right? Very good. So in microservices, how does it address? It makes a smaller piece of software, and then within that, what we are trying to do is break them into multiple highly cohesive low coupling software, so that any change in that software, small piece of software, that can be quickly deployed and take to time to market. Time to market will be faster with that. Right? The next comes an very interesting topic. When I design my microservice, what will happen? What is the problem of when I have a software which is having very complex, inherently complex application, and I'm building an inherently complex application. Microservice, as you see, the microservice is, you can write in a thread style, create, read, write, all these things. Thread style microservice. It is very easy to do that. So that can read, write, and everything. It's easy. But what if one of my class is dependent on another class, right? And one of the module, for example, let me take an example that I have given an example. You see this, I am the user. I am holding an HDFC bank account. So what I am doing is, from the portal, I am logging into the banking portal, and I am changing my address. And from the banking side, they will have another API. From their side, they want to track me. And when I change the address, they need to be notified that I have changed the address, and they need to do the verification as well. They need to send a letter. They need to send the ensure that I am living in the place where I have mentioned. So that problem is also there. Okay, so these kind of complex situations, what we do is we go for domain-driven design. Any complex software in microservices, microservices has any complex software built, we use domain-driven design. And if you see the elements of domain-driven design, any of the each individual elements of domain-driven design, they talk about coupling, how to be highly different, a big topic cannot be covered today, but I'll talk about the individual elements. So in this case, if you see this, I am the user, I log into banking context, which is my, it's called a bounded context. We create a bounded context, and we created another bounded context, which is customer context. So that's for the banking side to log in, and this is for myself to log in, which is for me, I'm a banker. I'm a banker. I'm getting into the bank. For them, I'm a customer. For banking system, it's a customer. So what we have is, except address and customer category, they can be shared. They are very similar. Only those classes are shared. Rest all classes are different. So to avoid type coupling, what does it give? Domain-driven design. It creates a bounded context. Within that boundary, the changes, the messages, the changes, the data elements has to be within that boundary. Bounded context is nothing but a boundary, right? And that happens at the aggregate root level. Any information that we want to access beyond the within the bounded context, outside of the bounded context, we communicate them through aggregate root level. Aggregate root is a tree. Think of it as a tree. It has many branches. That one class holds many other subclasses. So in this case, if you see this, the aggregate root is user, and on another bounded context, the aggregate root is customer. If you bring customer class, then it brings all the elements there. If you bring user class, it brings all the elements there, right? So user, and if I want to communicate my any of the, let's say saving account class needs the login summary, right? From there to there, I cannot directly communicate from saving account to login summary. The information held by user class will be communicating the customer class, and it can take from login summary. That's how it communicates. It's decoupling. So if this is not the case, how the flow will look like? Every class will be communicating every other class in the other bounded context. It goes to an extent. For example, if I am having a, let's say, a login summary, I want to see also, or credit card information, the customer context also want to see it. I am taking 5 fields of credit card, and the customer context in the banking side, when they see it, they want to see 20 fields of credit card. So 5 fields versus 20 fields. What we need to do? We don't keep them as the same class. We don't create one class. We create 2 classes. All this is because of low coupling. You don't want to couple them together. You want to separate them. So aggregate root level, we communicate them at aggregate root level. And the anti-corruption layer is nothing but a topic that we have just spoken there. See, this hardware, when we use the hardware, when we use remote procedure calls, when we use database calls, what is happening here? Any errors to another system will corrupt our system. It's the same. So in domain-driven design also, when we want to communicate an external system, we have an anti-corruption layer. And duplication of classes, that's what I just spoke about. In case if the same class is being shared in multiple places, we have duplicate the classes. And you see this shared kernel. This is shared kernel. Address is being used almost in a similar way. Maybe one field may be very similar they are, and it's a small thing. So I can share between 2 contexts. That is shared kernel. That's why this you see that mark and the customer category.
That is the balancing act. That is the balancing act of something. So it will be very easier to create a common thing.
Yes, both of them are common. So only in certain cases we want to keep them shared. So that is this case. and domain event. So now I want to pass one message to another component, from this component to another component. What you have seen is components, two different components. Banking context is one component, customer context is another component. So between these two components, I want to communicate some messages. The user has changed his address. That has to be go as an event, because what it needs to do is 3 or 4 different items it needs to take care of. One is it needs to inform all other banking system, and it also send an email notification to the end user. It also send a personal mail, regular mail to the end user to verify he is residing in that place. So it needs to interact with the multiple systems. So in those cases, we generate events. Events also I will talk about more. So I'm leaving another domain-driven design. Today just we cover anti-corruption layer. That's easy to cover. You see this, how the system would look like before this, because I have included as part of my service. It's called a domain service. This is part of domain-driven design. This external payment service is a domain service. Within that domain service itself, I'm writing my code, and that's how it would look like. If I write this, any problem in that system, the third-party system, the payment, it will directly affect my system, and I don't want to attach to my system. I want to detach it, so I detach this way. I created an adapter. Adapter is a design pattern. So design pattern always comes in handy, helps us. And you see this, I created as a separate adapter, and my domain service is also okay. Domain service would call this adapter, so my domain would not get corrupted, right? So this is anti-corruption layer. This anti-corruption layer we have spoken for communicating any external calls, including database. Now you have seen the component level problems. One is microservice, another one is domain-driven design. Domain-driven design and microservices are going in hand in hand. If your software has too much complexity, then go for domain-driven design. Otherwise, the regular CRUD is sufficient. Now we are going to see the problems at the system level. So when I have the system that has problem of, I'll talk about this. My system needs lot of reads. I read a lot, but my write is very less. Or I have one read, one place where I'm going to display, but my system gets write from multiple different places, right? So or my write is more, my read is less. You see this imbalance is asymmetric, right? When it is an asymmetric, my read and write is not as same as equal, right? So in those cases, what I need to do? That's when it comes CQRS. So without CQRS, what we are trying to do? We are trying to put in the same system, and what's the problem will come? Performance problem, right? Because when my reads are very high or my writes are very high, you put in the same system, same CPU, same memory, everything is same. But you try to use them for both of them. So what we are trying to do is, this is at the system level. At the system level, when you put all of them together, we are getting into performance problem. And to solve the performance problem, we need to decouple. Because read and writes are coupled together, tightly coupled. That's the problem here, right? So I'm segregating write as a separate AP, read as a separate AP. And you see the event. Event is the sync up mechanism that goes from write database to the read database every time. In this approach, what happens is it's no more coupled and no more as if, because it's what is this? This is eventual consistency. Because at the time of writing, the sync up event does not happen, then the read AP would not read that. It's eventual consistency. I mean, decide based on your requirements. This needs to be strongly consistent. then it's not this solution. Right?
So what the
Yes, it's a challenge, software challenge. We have many other solutions, but we'll see one by one. Okay. So event systems, any asynchronous calls, what we are trying to do is whenever we make a call, we tend to wait for that response. Right? If we tend to wait for that response, what happens is it's a tightly coupled system. So it's not always necessary for us, right? So in that case, what we try to do, we decouple them in an asynchronous, through an asynchronous call, fire and forget. And EDA, event driven architecture, and event sourcing. So we'll talk about this one now. So EDA, the problem here is, you see my producer is there, my consumer is there, right? Okay. Now, it's a producer-consumer problem. My producer produces more in a short span of time. 1 hour, within an hour, my producer produces 1 lakh records, and the consumer goes on 1 by 1 record, and it has whole time, right? Now, if you are expecting the consumer consume it quickly, if you couple the system together, these are two different systems. If you couple the system, tightly couple the systems, what will happen? Without these streams, if you directly call this consumer 1 lakh records at a time, that will kill the other system, right? And also downgrade the performance of. So what you need to do is, you need to separate them, decouple them, the producer and the consumer, through event streaming, and that's what called event driven architecture. Right. How you have seen? Yes,
We get the
please.
slides. We get the slides of this.
Definitely. So far, all we have seen is coupling, time coupling. We decouple them. You see the evolution. Hooks have come 30 years back. It has come, and design pattern, design principle, all we have applied is for decouple the system design. Be it code level, class level, any level, it's decoupling. So the event sourcing is another problem. So what happens is, if you go to a shopping cart, you are adding each and every items that you want to buy, right? So when you add it, what happens? You got generally without this screen. Generally when you add it, how do we traditionally team? We create one shopping cart, empty object, and we go and add the items in there. It's a state machine, correct? Because when I add items there, I need to, every time when I add, is it valid, is user logged out or whatever reason, I'm going to check it. That's a validation, and I'm going to add it. It's a state machine. It's going to add the data in it, right? So event sourcing, what it tells is, you decouple them. You decouple them because one state machine object is holding everything, and you are going to validate every time whether the object is valid, relevant, irrelevant, and removal, etc. Right? So what we are trying to do is in another way called event sourcing. Instead of state machine, it appends the item. Okay? So what happens is, in event sourcing system, through an event, we control. Event is always a decoupling, right? Software is completely decoupled because one part of the system, the producer is decoupled, the consumer is also, and another side is completely. Through an event only we take care of it. Event that you see here, a card created, item on added, everything is immutable. Event is an immutable. It advertises what I am doing now. The consumer takes the responsibility, right? Once the cart is created, I am sending an event. First is item 1, I am buying a shirt, I am buying a pant, everything is added. Now the user removes an item from the bucket. That's also an event. Everything is an event. Because the event systems are immutable, the design is immutable, there is no change, change is not happening. It appends the record. In the database if you see it, it's +1, if they remove it, it's -1, of the same item and it appends the record. There is no change in the state. Imagine a database record. Earlier case, you are having one record of shopping cart or an object. That records gets changed. Your shirt you have added, shirt is 1. When the user removes the shirt, now shirt it becomes 0, correct? Or the record itself get deleted, soft deleted or however it is, however you are reading it. But with the event sourcing system, +1 shirt is added in the shopping cart in the database. There is another item, -1 shirt will be there. When you are picking up the data, you are going to sum it up. In the summary, when you summarize it, the shirt becomes 0. That's how the items are removed. So there is no mutability. So immutability is also another way of decoupling. I don't want to change the state. So that's event sourcing.
In normal system, when you are experimenting with the quantity, we can see that people add new row for the same item as a new quantity.
Correct.
We update the same.
Exactly. Yes. Exactly.
So in your case example also, I mean, we'll always play around with the same row instead of adding a new item.
Exactly.
But you said that we'll add a new item for anything that really have any change in the that particular object.
Correct. So that's the purpose of this event sourcing. Because I don't want to change my state every now and then. Rather, I would append. Correct. What you are saying is exactly correct. That's event sourcing.
But in a normal microservices and all, I haven't seen this way that people.
No, this is another architecture. So event sourcing architecture that comes into handy when you are changing a state too much and that causes a lot of problems. Then you go to event sourcing system. So it is based on your need. If you are not applying the event sourcing system into your microservices, then this does not exist.
Because this will come at an additional cost, right? You have a data cost, you have a DB cost, you have a S3 cost, you have a processing cost of it. So
yes, it has its own challenges. Because if you see this archiving is also the data archive, because data gets appended and you need to archive the old data and you need to save the data for replay because event sourcing systems should be replayable. So when you are diagnosing the problem here, how you will be diagnosing? I can resend all those events once again. How it is being reproduced in a lower environment to debug an issue, I can replay it. When I replay it, first it goes to cart created, item 1 added, item 2 added. That's where my error has happened. Okay, I can identify the error. So that's what I mean. It's another different topic, big topic.
Basically, microservice pattern.
Yes, microservices can adapt to event sourcing. Anything that can do it, but any software procedure can handle it, but most appropriate is microservices.
We can customize this how we need it.
Yes.
Even temporarily using the event sourcing and then later on.
Yes.
Is this what is equivalent to Kafka? I mean, Kafka, the creation of Kafka is based on this principle only. The DB persisting is a time-consuming stuff. So the real stream of sequence, right? Whatever has been even appended, the new row gets added into the stream.
Correct. Kafka is a messaging system that takes care of it. Again, if you think of service bus also, Kafka is one of the service bus or Azure service bus, whatever it is. It decouples the system of producer and consumer problem that we have just spoken about. And then another way of decoupling the producer and consumer. The Kafka and service bus messaging system is, they are records, not events. So we handle them differently. These are the few things that I have. If you go through it, there are many other items in software engineering. They are tightly coupled. And every time we invent a new solution, that's of decoupling the problem.
But in the Kafka, you always create an event. So each event is easy.
Yes.
And event are recorded.
Correct. Correct. Yes.
Right. I think this is came from here what when in real world, nothing gets created. Yes, in the real world, whatever event happens, it happens.
Yes.
It won't change.
Yes.
Because it's time series
Correct.
way of
Correct.
I usually get sometimes confused with event architecture and
Event sourcing. Yes.
I think both solve the same problem in a different way.
Okay, I'll explain that. So EDA is events are driving the system. Events drive the system. That's event-driven architecture. But in event sourcing, what happens is you see this. I'm taking the every bits and pieces of immutable events. I'm keeping it in my database as series of events. That's the difference. EDA is for just an isolation. It's just isolating the problem. So here the problem is the producer-consumer problem. That's the difference between. And even when I have multiple consumers, right? So I have one producer that has to be consumed by multiple places. That is EDA.
Right. So in event sourcing scenario also,
Yes.
in event sourcing scenario also, events are happening, right?
Right.
And I'm generating events.
Correct.
So that's where also event is getting published.
Correct.
And somewhere it is getting persistent.
Right.
Event architecture is also seems to be in the same way unless I'm not talking about technology.
Correct. It's very similar. I mean, the
Now
concept
that
is
if
end
I'm
of the
not
day,
in
in the middle part, it's events, right? The middle portion that plays a big role is events. Because if you see this stream, that stream is responsible for publishing the events to the corresponding consumers. And there also, it's events. These events are being consumed by the consumer at some point because they all get into the store. Instead of directly consumed by the consumers, it all being stored in the database. And the events play the critical role here. Both the places, the centralized concept is events.
Maybe the use case is different, right?
Use case is different, obviously, because that's why we have two different the technology systems.
Maybe for EDA, it might be useful for real-time data.
Real-time data.
So here you cannot do that.
Yes, correct. That's the very important point here. See, my intention is I want to receive the data. So even if you see the previous question, if you want to have the synchronous, the most sooner I want to get the information. I want to achieve almost real-time or ASIC style data. That's when we need EDA. Because as soon as something happened in the system, I notify through events, the other system gets consumed. But it's not the synchronous, it is the most possible way of getting the synchronous data.
Near real time.
Near real time. That's the correct word.
I think one of the use case of event sourcing is even to make a workflow system.
Workflow systems. Yeah.
Because maybe there is one document
Yes.
that want to modify, okay, and then
Exactly.
someone approve it. I think about that kind of thing, event sourcing is
The best. Correct.
One question here.
Yes.
When we
please.
talk about event system,
Right.
we say we are decoupling the producer and consumer, right?
Right.
But there is no deterministic outgoing throughput for the producer. Say for example, in time of big billion day, the producer can spike up the outgoing traffic. But there is a deterministic polling interval given for a consumer. So there will be a invisible coupling where the queue would be clogged, and there is a type of coupling, right, between the producer and consumer.
You are talking about EDA, the stream.
Any event system.
Correct. Oh, no, that's not coupling because I send them. I'm not waiting for the response for me. I fire and forget it. I fire the data
Okay.
and I forget about the data, whether that is consumed or not consumed, it's not my problem. What we are bringing in is that the sole responsibility of the stream. In this case, its stream is, assume that it's an event hub, right, in Azure, or it could be a service bus or Kafka, whatever it is.
Yeah.
So its sole responsibility of that service bus or Kafka is retain that message until it is correctly consumed by the consumer. If the consumer is not able to consume it correctly, then it will replay it. Once again, it will send it. But if you see this, the producer and consumer are detached, but it's not even attached to the stream itself, because it does not care about stream. What stream is doing, it's not its job. And the producer also does not care about whether the consumer consumed or not consumed. It does not care about it. For example, if I am publishing an event in a payment system, I publish to say service bus, I paid the payment. I don't care about whether it's really paid, or I can guarantee assured that it's a service sole responsibility of service bus to deliver correctly to the end system. Okay? Because the guarantee, what we call service bus is a guaranteed delivery system. Guaranteed delivery system means as long as the consumed is correctly consumed the data, it retains the data. Even if there is a failure, it puts them into the special queue. It keeps the messages there. It never gets lost. Correct.
I think what he's saying is that the coupling that he's mentioned is the stream itself going on.
Yeah, correct. When we segregate the responsibility of single responsibility for each of them. Producer's job is produce message. Done. I don't care about the other thing.
But if the stream is down, you can't.
Yes. If you look at it, it's highly cohesive because they all do their one job. Consumer's responsibility is consume. This job is job of stream or service bus to retain the message. That's it.
It's an asynchronous system.
Asynchronous system, yes. The producer consumer problem.
Right. So, if I understand this question, it might be I'm thinking some other point.
Correct.
Determinism is there of load at producer.
Correct.
How determinism would be that I have to escape for consumer while consuming? Because when the spike comes from producer,
Right.
we know that a lot of this load coming up, I have to escape.
Right.
At consumer side, do we have that determinism that I'm having too many things to process, I have to scale linearly?
There are absolutely. That's a very good question. Okay, so we have so many mechanisms. If you see this the spike happens at the producer level so much high, and what you need to do is if you create as a function app, Azure function app as your service portion, it automatically scales up the number of services. It auto scaling option is there. So as soon as it detects the number of messages are spiking up, it automatically scales up. I'm sorry, I have only 2 minutes to finish it up. The last thing is, I'll take up 1 or 2 questions, but I'll conclude here and I'll take more questions. See this. Be it any level of software, we have seen 4 levels: code level, class level, component level, and then system level. Any of these things, just decouple it. Just 1.5 minutes. Any more questions? Please. Right.
When we talk about event sourcing, when we can materialize a view of the source of events, so what is that materialized view like? For example, is it like when we did a transaction, it's a checkpoint. Checkpoint is here. Here it's a checkpoint and I can look at it. Materialized view meaning real time. What is it? Is it one other record with a specific tag on it or how do you do it?
Okay, so that's another portion. Okay, it's not. Okay, you see this materialistic view is a consumer. What I'm trying to say is I'm decoupling of my system, which is the from presentation to the materialistic. I'm decoupling of these 2 systems. Why I want to decouple the system is because I'm going to create a an object of state object. That state object is going to hold it. Rather than that, this materialized view now, the publishing the view, you see the publications from here, these events, these consumed data, it sums up. The role for this materialized view is sums up, summary it, and display it. Rather than directly displaying it. In regular cases, from the presentation, if you see this materialized view, that view is having reading a database object, and it shows up the data there.
So the materialized view will be kind of, it will be a state machine again, but it would build it based on the
Events, instead of directly doing it,
yeah, we are doing it so that we can play. And yes, it's something related to blockchain, because blockchain also does the same thing.
yeah, similar concepts. Blockchain appends the data. Thank you so much, friends, and it's engaging and we have.
Thank you so much.
It was really interactive session and so much informative.